Hi students, you know that MySQL is a database management system based on relational model. We had defined the term DBMS or database management system in preceding lesson. Now you need to know about what the term relational means, and this is the subject of this lesson. The concept of relational database management system was founded by Dr. E.F. Codd at IBM in 1970. This concept envisages storage of data in most obvious and natural way, that is in the form of tables. However, the tables have to have certain specific characteristics, not just columns and rows as is normally perceived. Dr. E.F. Codd had formulated 12 rules to define the relational model of databases. Those 12 rules are to be strictly adhered to for any database system to qualify for being called as relational. Actually, none of the commercial database systems available in the market follow all the rules going by the criteria of ideality, but they are very close to the concept. Codd named such tables as relations, and hence he coined the term relational in the name RDBMS. A relational database management system must have by and large these properties. Data must be stored in the relations, that is normalized tables. And another important property of the RDBMS is non-procedural access using SQL. SQL is structured query language, which is actually the prime subject of this course, and it is a non-procedural language. The third important property of RDBMS is the concept of null values. That is, the value should not be provided in a place where if the value is not applicable or if the value is not available, because any substitution of a value, say for example 0 in place of when the numeric value is not available, or a blank space when a string value is not available, does not actually represent the fact that the value is not present. Constraints, that is data validation. He advocated that the data validation must be the job of the database, because finally the data is going to be stored in the tables, and so that too in the columns of the table, and so the constraints must be defined on the columns of the table so that there should not be any bypass to it. There should be a non-procedural definition of the constraints in the form of objects to be created on the columns so that the data validation will be implemented in the very place where the data is stored and there is no way to bypass it. Then the RDBMS must implement the concept of relational algebra. It is actually the derivative of set algebra, which we have studied in the school days, and the only name is relational algebra. The set algebra has made applicable to relational algebra. There are 7 operations which are performed under set algebra, and so they are also present under the relational algebra, like selection, projection, Cartesian product, join, union, minus and intersection. So all these operations we are going to perform through SQL, because SQL basically is the implementation of relational algebra coupled with another mathematical branch related to the RDBMS, that is called as tuple calculus. The next important property of the RDBMS is view. It is an alternate way of accessing the data by allowing to create an abstract layer while the data still be stored in the relations only. And because of the views, you can hide the actual source of the data and also avoid certain complexities. Now this lesson we will see how a common table differs from a relation. As far as the other properties of RDBMS are concerned, they will get covered eventually with the respective topics as we progress in the course, but for now just remember them. Now summarily, a relation is a table which contains the data about only one type of entity. So for example, you look at the table on the top. The table has columns like student ID, name, subject, fees, teacher, phone. Now, why should I call this as a table? Because it contains data about two types of entities, students and subjects. So you can see that among the attributes or among the columns of this table, there are some columns which belong to the student entity, while there are some columns like subject, fees and teacher which belong to the subject entity. Now you may face problems while handling the data in such tables. For example, if we want to change the fees for any subject, then it will have to be updated at multiple places as the fees is repeated. So also the same problem is with the teacher. You can see that I have highlighted that part with green, and so the fact is getting repeated. For example, the fees of chemistry is 700 and the teacher for chemistry is Diana is repeated for equal number of times as the number of students. Now if I want to update, I will have to make the update at multiple places. This is an unnecessary repetition of the fact, and so this is called as redundancy, and we need to avoid primarily this redundancy so that there will not be any problem in handling the data as far as insert, update, delete and selection of the data is concerned. But now you can look at the set of tables at the bottom which are derived from the top table only. They display the same data and facts, but here we have separated the tables, one for student and another for subjects, while keeping the subject column common to both the tables. You can see that the students table as well as the subjects table both have the column subject common to them, so that we can relate the students table to the subject table, and the redundancy is removed. Now update for fees or teacher is simple to be made at just one place. Moreover, through an operation of join, where we can equate the values of the subject from both the tables, we can also know the fees to be paid by the student for taking a particular subject. The above table, the table on the top, is called as table because not all the columns can be bound in one single relation. So sometimes in theory of the databases, it is also called as universal relation, the top table I'm talking about. However, in the tables at the bottom, the columns in students table only represent the attributes of students, while the columns in subject table represent attributes of only the subjects. So columns in each of these tables can be found in one single relation, either being belonging to student or being belonging to subject. Actually, this decomposition of original table of the top was done through a process called as normalization. The purely theoretical concept has been kept out of purview of this present course deliberately. The purpose is to keep the things as much simple as possible and not to involve too much of technicality, and so I have avoided the explanation on the concept of normalization. But it is so much intuitive that when you actually come across such a table like you have here on the top, that is universal relation containing mix of the attributes in one table, then you can separate out the concerned attributes of the particular entity into different tables, and this way you can perform the normalization in the most simple way. Now we formally define the relation and the term Relational Database Management System, that is RDBMS. You can see on the top the definition of relation. Relation is a table which represents columns of only one type of entity, that we have already seen. There is at least one column designated in the table which can help us to identify each row uniquely, and that is called as primary key. For example, in the students table, student ID is the primary key which helps us to identify each student uniquely. So also subject is the primary key in the subjects table, and down the line we have the definition of relational database management system, which makes the use of the definition of the relation. Database system that consists of data stored in relations is called as the relational database management system. Those relations are related to each other by way of PKFK. PK stands for primary key, FK stands for foreign key relationships, with the constraint that column designated as FK must contain a value only from values already present in the related PK. So here you can see that we have the subject column in the students as well as in the subjects table, and the PK-FK relationship has been shown over there. The subject column in the students table is FK, that is foreign key, because it refers to the primary key column of the subjects table, and the column name is also subject. And you can have in the subject column of the students table only such subjects which are already registered under the subjects table, and no such subject which has not been registered can be used under the subject column of the students table. Thus guys, we arrive at the end of this lesson. Continue with the next. Thanks for watching.